Hello and welcome. I wanted to go over the homeostasis worksheet with you because that seemed to cause a lot of struggle, and it should have. It was hard. And so, number one, the first thing that I want to emphasize to you is that positive feedback adds to the problem or the condition. So, if you think of positive as addition and negative as subtraction, then you should get these right as far as whether they're positive or negative. So the first one, as a person gets dehydrated, their blood volume becomes thicker and harder to pump. Osmoreceptors in the hypothalamus monitor the amount of water in the blood and activate the pituitary gland, which releases a hormone called ADH. This in turn signals the kidneys to stop producing urine, and the water from the urine is redirected for use in the blood. So, is this correcting the problem or making the problem or the condition um, exaggerated? It is correcting the problem, so that would be an example of negative feedback. So, then remember that all of these situations have a receptor, a control center, and an effector. The receptor is what is detecting the problem. So in this case, it's the osmoreceptors in the hypothalamus. So the receptor is the hypothalamus. Osmotic means water. Control center is what initiates the change. So what is correcting the change? So that's the pituitary gland by releasing more ADH. And then the effector is what organ is affected that's going to correct the problem. So that is the kidneys, which stop producing urine. The second one, as a person's blood sugar lowers, the pancreas detects a decrease in blood sugar levels. The pancreas then releases a hormone called glucagon, which tells the liver and the muscle tissue to break down stored carbohydrates and release sugar into the blood. So the receptor in this is the pancreas because the pancreas is detecting. The control center is also the pancreas because the pancreas is releasing the hormone that is going to change everything. And then the effector is the liver because the liver is going to break down the stored carbohydrates and correct the problem. So the problem is being corrected, so that means that it's taking away from the problem, changing it negatively, and so that is negative feedback because it's not making the problem, it's not making the blood sugar even lower, it's correcting it. So it's the opposite, so that would be negative. The next one, number three, blood glucose concentrations rise after a sugary meal. The pancreas again monitors glucose levels. The hormone insulin is released from the pancreas, which tells the liver and muscle tissues to transport glucose out of the blood. The blood glucose levels decrease. So it's taking away from the problem of high glucose, so that is going to be negative feedback. The receptor was the pancreas, and then the pancreas again released hormones, so that is the control center. And then those hormones, where did they go? They go to the liver and the muscle tissue. Number four, when a tissue is injured, such as a blood vessel, the tissue senses the injury and releases chemicals called clotting factors to activate platelets to stop bleeding. The platelets then release more chemicals to activate even more platelets to stop the bleeding. So it's going more and more. So this is positive feedback. So the receptor where the injury was the blood vessel wall, and that releases chemicals called clotting factors. So the clotting factors and the platelets are the control center because that's what's changing the situation. And then the effector, what happens to correct it is that the platelets adhere to the site. So they stop the bleeding. Number five, oh, yeah, so that was positive feedback. Number five, a baby begins to suckle, which stimulates nerve endings in the breast. Neural pathways carry the stimulus to the hypothalamus, which causes the release of oxytocin and prolactin. Tissues in the mammary gland release milk. The hungry baby continues to suckle, stimulating more milk release until she stops. And so, as um, more and more of the suckling happens, more and more milk comes. And so that is positive feedback. So the receptor was the nerve endings in the breast because they stimulated the hypothalamus. The hypothalamus is the control center because the hypothalamus was releasing the chemicals that are going to work on the mammary glands. And so that is positive feedback. Number 6, if calcium in the bone decreases, the parathyroid gland senses the decrease and secretes a hormone called PTH. This hormone triggers the bone to release calcium into the bloodstream and for the kidneys to stop excreting calcium in the urine. So if it's stopping the excretion, then it's going to increase the amount of calcium in the blood. So it's correcting the problem, not adding to the problem. So that is negative feedback. The receptor is the parathyroid gland because that's where the sense receptors were for calcium. The control center is also the parathyroid gland because that is the organ that released the hormone that's going to affect the kidneys. So then the kidneys are the effector because they stop secreting calcium. And it also affects the bone cells. So that you've got two effectors there. Number 7, if the blood temperature rises too high, specialized neurons in the skin and the hypothalamus of the brain sense the change. The hypothalamus sends signals to the blood vessels of the skin, causing the skin to sweat and vasodilate. As these blood vessels dilate, more blood flows close to the surface of the body and the excess heat radiates from the body. So the receptor is both the skin, because the neurons are there, and the hypothalamus because that detects the change. The control center is also the hypothalamus because that's the one that is going to signal the blood vessels to dilate. And when the blood vessels dilate, that is going to affect the arteries in the skin. Cutaneous means skin. So the arteries that provide blood to the skin, and that's why your skin would get red because those blood vessels are dilating, getting bigger, and then the heat can radiate. So it's correcting the problem, not adding to the problem. So that means that it is negative feedback. If the blood temperature falls too low, specialized neurons in the skin and the hypothalamus of the brain sense the change. The hypothalamus sends signals to the blood vessels of the skin, causing vasoconstriction. So the vessels are now going to get tighter. And as the blood vessels near the surface of the skin constrict, then there's less at the surface, and so it's going to retain the heat. So this is also negative feedback because we're changing the situation. The blood temperature is going to not get lower, it's going to do the opposite. So that is negative feedback. So the receptor again is the skin and the hypothalamus, and the control center is the hypothalamus, and the effector again is the arteries in the skin, but it's the opposite situation. So both heat and cold correction would be negative feedback. During childbirth, this is the one that you always see for positive feedback. During childbirth, the stretching of the uterus sends signals to the brain, and the hypothalamus tells the pituitary gland to release the hormone oxytocin, which stimulates stronger uterine contractions and speeds up labor. So the stretching causes more stretching because stronger contractions are going to do that. So that's positive feedback. The receptor is the uterus. That's where the stretch receptors are. The stretching sends a message to the hypothalamus, and the hypothalamus is the control center because it's going to control what's going on with the problem by releasing or telling the pituitary gland to release oxytocin. So it's acting on both the pituitary gland. The last one, number 10, is the walls of arteries stretch in the presence of high blood pressure. Baroreceptors, barometer, so detecting pressure, located in the walls will also stretch as a result and relay a message to the brain. The brainstem sends a message to the heart and the blood vessels. The heart rate decreases and the blood vessels increase in diameter, which cause the blood pressure to fall back within the normal range. So we're correcting the problem, not adding to it. So that's negative feedback. The baroreceptors were the ones that detected the change. The control center was the brainstem because the brainstem is going to send the message to the heart and blood vessels. So they are going to affect the heart and blood vessels. So the effector are those. So I hope that helps um, you to understand how the receptor, the control center, and the effector work together to maintain homeostasis.